Okay, so first, super quick bio. Who am I? So I did my master's, finished in 2002 in Luleå. And ever since, I've been working with software development of different kinds in different companies. And in 2014, I started at ABB Industrial Automation. And then in 2019, I finally got to start my PhD at the Array postgraduate school. So I'm an industrial PhD student, as you understand, and I did my licentiate in 2020. And I also work as a cybersecurity engineer at ABB, so that is the reason my research is oriented toward this area in general. So what is industrial automation and control system, and why are they important? I think that this is like running through open doors. You already know this, but I mean, of course, industrial automation and control systems are very important for us. They provide us with clean water, as you were talking about. They generate the energy we need for the society. They run lots of the production systems in our world. So clearly, they are important for us for different reasons. And you also know, since you are in cybersecurity, that we live in an increasingly hostile world. As Sarah said, the manufacturing systems are actually one of the systems being more and more attacked by we live in an increasingly hostile world, and of course then cybersecurity is of growing importance. Access control is one area that I think require additional attention in both the current and future industrial automation and control systems. I will talk a little bit more about why this is important, but this somehow ended up being my research topic. Why is ABB interested in this? Well, my part of ABB, process control platform, we develop DCS system, distributed control system components, and we work with R&D related to these different components. It's hardware, software, it's electronics, control and I/O, and so on. Everything, you could say, on the north side from the sensor and up to the operator workplace. So of course, from a ABB perspective, this is an interesting system type, and cybersecurity is, of course, a business requirement, but it's also important for ABB from my research on access control. So the idea, of course, is that my research and the development projects within ABB will have help from each other, more or less. Some of the questions come from the research or from the development projects, and some of the contributions of my research project is added into these development projects. Okay. And now I don't have control anymore. Okay, so there it is. So to be on the same page, what is access control? A short recap. You probably also know most of this already. It describes and enforces who can do what in a system. And this is, of course, not limited only to digital interactions. You have all used access cards to get through a gate, or you bought the ticket to get into the concert. Money could be one kind of access control. So in access control, there is some kind of intent. You state an informal policy, you kind of formalize the rules, you get some kind of enforcement methods, and then you have some effect. I can exemplify this with traffic safety. We talked a lot about traffic this day. So you could say that the intent is that we want to decrease the number of accidents in traffic, and we want the traffic to flow smoothly on the roads. So we decide that, okay, only people who really know how to drive, who know the rules, they should be allowed to do that, as long as we don't have automated vehicles, that is. So we have decided on, okay, we have licensing to be allowed on the roads, and to be allowed to borrow or hire or buy cars. So that is the formal rule. And you maybe need to pass a test to prove your skills in order to get this license. And maybe you need to go to school to acquire those skills. And the enforcement here is the traditional law enforcement. You can get stopped by the police, and probably you cannot even rent a car if you don't have a license. What is the effect then of this access control policy, of this access control mechanism? I would say it's very effective. I mean, I think this actually saves lives every day if we didn't have this kind of access control set up in the real world. But what about the digital world? So, because that is, of course, the main focus today. So the state of the art that you all probably also know about is the least privilege principle, which means that no one in the system should hold any higher privileges than needed to perform its tasks, and the other way around as well. You shouldn't have lower privileges than you need to fulfill your task. This is not extremely easy to formulate and express in formal rules, but this is what we all strive to reach in the digital world. And to do that, we have three major disciplines: identification, which is keeping a record of identities for the different entities in the system; authentication, to provide proof of the identities; and then you have authorization, which is the rules describing what identities or what actions can be done by who on what resource, more or less. This was an extremely short and simplified version of what is access control, but just so to be on the same side. So what is the current trends and state of access control in industrial automation and control systems? So the current state, or at least the current state until for a few years ago, is that we have very hierarchical, segmented environment where different functions were on different layers and talk to different proprietary protocols, and related to access control on the higher levels, you usually could have quite well formed rules for user interactions with the higher level systems, but on the lower levels, you could have something or you could have nothing, but usually or quite often we saw that, do you know the protocol? Then you can do pretty much whatever you want. And you know that there's a trend toward network-centric design strategies. We have one network backbone and all the devices talk on this, using this network backbone. There are also trends toward adaptable and flexible production. And all this is supposed to be in a service-oriented approach. So we kind of need a unified method for expressing and enforcing rather fine-grained access control now on all levels in the system. And it has to be lightweight, it has to be scalable, because we want to allow enforcement also on resources protected by embedded devices, which are typically not very advanced in like handling big amounts of data and so on. And also we need, it has to be possible for easy reconfiguration. So some of the challenges here is how to formulate and maintain these access control policies. This is something I think you mentioned as a negligible cost. I would say it's not negligible. It's quite time consuming and difficult to actually do this in a good way in a complex and dynamic system. How to enforce these rules, and how to handle the increasingly autonomous digital entities, because these also interact and probably should follow some kind of rules. They cannot interact in any way. And my research has been to look at some angles of these challenges. So in the process industries, which I work in, there is an emerging system type which has some of the characteristics of I've talked about here with the network-centric design and flexible production. So I just briefly talk about modular automation, And in principle, it's Industry 4.0 for process orientation. So see if we can do this quickly. Okay, so on the physical layer in the bottom, you have well-defined physical entities. They have separate control. And the physical and logical interfaces of these modules are well defined. That is the MTP module type package. So you can build your system using a number of modules, and then you can change your system to adapt to your current needs. On the supervisory control, you have a digital orchestrator who, using recipe descriptions, know exactly what is supposed to happen in this system. It executes recipes. And these recipes, they are of course changed when you change whatever you want to produce in the system. And then you have human users looking kind of at operations layer. You have engineering, maintenance. But most of it is actually the operator saying, now we want to run this recipe. And then everything happens. And then the manager comes and say, okay, now we want to change something. We need to scale this system up. Okay, we buy 20 more of these and 20 more of these, or we hire. So what actually happens is that you have a system which you don't have a baseline behavior for. It will change over time. When you design it, you don't know what the components are and how they will actually communicate over time. And that is, of course, interesting properties for cybersecurity. So I will talk about two different studies that I have done related to these kind of workflow-based automation systems. And the first study is about policy formulation strategies. And here we look at some strategies and discuss how these strategies compare to the least privilege principle in the workflow-based system. And then we implemented these strategies and evaluated them in a simulated modular automation system. And we used the multi-agent system based on Jade. I don't know if you know about Jade, Java agent development. And using a range of attack scenarios, we try to evaluate how well the different strategies could counter different attack scenarios. The first three strategies here are kind of what we see sometimes in reality. The two D&E, they are kind of evolving versions. We have never seen them, at least in industrial automation and control systems. I know that they exist in some specific workflow-based systems, but not in the industry. So in this study, we simulate everything. So we don't think about the different quirks and problems with protocols and how well will this work in reality. This we do in the follow-up study. I should mention that when I say we, I mean me and my supervisors, Hans Hansson, Ida Schauswitz from MDU, and Thomas Lindström from ABB. I forget to put it in the slide, but they are, of course, extremely important for me. So in the following study, we also look at policy enforcement, and then we need to look at the actual protocols. But to understand the enforcement architecture, we need to talk about what are the typical components in an enforcement architecture. So you need some place to store the policy data. You need to be able to administer the policy data. When I say policy data, that is pretty much authorization, the authorization rules. In my work, I say that identification and authentication, that is already solved. You cannot solve everything. Policy information point, that's just somewhere to query policy data. Policy decision point, that is where you actually take the decision. This access request should be accepted or denied. And the policy enforcement point, that is where the decision is enforced. So the policy decision point and enforcement point we thought were the most interesting ones. So we also here looked at the number of strategies at some commonly used enforcement architecture patterns, more or less. And then we reasoned about how well these architectures fit with distributed and dynamic access control systems. And of course, here also we have the modular automation system as a kind of use case. So we have many clients and many resource servers. When I say resource server, that's typically a controller which has a number of IOs connected to it, or a connectivity server with a number of IOs connected to it. But we also have a kind of centralized view of what is expected to happen in the system. That is, which are the active recipes in the system. That is what we know should happen in the system. Okay. First alternative was looking at putting all the logic in the resource server. We didn't think that was a well-adapted version for dynamic scenarios, because the view of what is supposed to happen in the system is, as I said, somehow centralized. If we would have all the data in the resource server, we would have to push a lot of data all the time to lots of different servers. Bad design, we thought. So the second alternative is using the resource server, communicating directly with an external policy decision point. I mean, this of course works, but it puts a lot of strain on the resource server. It has to communicate a lot, and the resource server we know should actually spend most of its time controlling the physical environment. So we thought it was not really adaptable for the embedded solutions. Third alternative is to put the policy decision point in authorization server. It's in the same way, but letting the client mediate the policy decisions using some mechanism. So what we use here is JSON Web Tokens or something similar. I think that there are not much similar though, but JSON Web Tokens is what you usually use when communicating access control decisions between parties without the mediator being able to alter the decision. This of course also works, but possibly it's a huge load on data for clients to mediate if we will have all the policy decisions being required to be mediated. So what we ended up with was a kind of combination where we had put some logic in the resource server and some logic in the authorization server, and the authorization server had the dynamic part, and the resource server contained static, the static parts. We thought this was the best fit for the problem that we stated, and we did some implementation of this and are now working on how to evaluate this and integrating it into some realistic system. So I think this is in principle what I want to say. What are the future plans? Well, as I said, the integration of these two prototype works into like a more realistic system, and then to perform validation and experimentation on these implementations. And what we have done is started to build a modular ice cream factory as part of a EU project. And this ice cream factory contains kind of the different components that we saw from modular automation with the, unfortunately, the simulated ice cream factory done, but with separate control, common simulation, orchestration, engineering operations, and yeah, we'll see where we end up with that, but that is my current focus in getting this to work. So, as a summary, access control, it's an important aspect of cybersecurity in industrial systems, of course. And the evolving system types is not, you cannot use the old methods for access control in these systems. You have to have something more unified. And that is exactly what my research looks at. how to infer, and how to enforce dynamic access control policies. Yeah, that's it. Thank you for listening. Questions?
Right now, if you go back, I think 2 or 3 slides where you have the schematics of your system.
This one?
No, one or 2 more back.
This one?
This one, yeah.
Okay.
How do you identify if access has been revoked by the authorization service?
So that is an interesting question. How do we know if it's revoked? In JSON Web Token and OAuth2, you don't have revocation. So what you do is you have short lifetimes on the tokens. That is the way you do it. We have been really discussing, can we suggest some extension here so that we can actually revoke policy decisions? Because as you see, these decisions, they are lived for at least, for the session. And the session will be limited somehow. And I guess that if it should work, if we want this to work, the lifetime of the session has to be of a lower magnitude than the dynamicity in the system. So currently that is what we rely on, but I would like to have revocation functionality as well. But as we work in industry, we want and have to follow the current standards. I mean, that is why we do it exactly like this. The standardization for JSON Web Token and the OPC US standard, which is what the network protocols are that we use. Was that a question? Yeah.
Any other questions? Okay, thanks.